Today, I will explain to you about simultaneous production of gas cap and oil column while injecting water at gas oil contact. Okay, me and my friend will explain to you the introduction, problem statement, methodology and result of the SPE paper that we extract. The objective of SPE paper is to show us the concept of producing gas cap and oil column while injecting water at gas oil contact. In petroleum engineering, there are three types of reservoir, which are oil water reservoir, water gas reservoir, gas oil reservoir. If the reservoir containing two fluids, which are gas and oil, there will be gas oil contact. Same with others such as water gas contact, oil water contact. This paper shows us how to maintain the pressure by injecting water. It also uses the electrical submersible pump. This pump injects the water at gas oil contact at high rate to overcome the gravitational force. This paper also shows us the location of the injector and the producer. The horizontal distance between the injector and the producer is about 12,000 feet. The structural elevation between the producer and the injector is 425 feet.
Let's proceed to the next section of this presentation. I will explain on the basic concepts and the model description of this study. There are two types of problems in this study. I will classify this problem into two, which is internal factors and external factors. The first internal factor is we want to produce oil and gas simultaneously with a reservoir that has a low dip angle. The second problem is this type of production needs to overcome gravity effect when injecting the water at the gas oil contact. Proceed to the external factor, which is immediate market of gas. It means that the gas has high demand in the market, so the gas and oil needs to be produced at the same time, so it will be more time saving. It needs to be reminded that this type of production will not work in anticlinal structure. It is because the gas cap overlies the entire oil column. An anticline is a structural trap whereby the rock layer is being folded. In such a structure, the gas oil contact is large, so the isolation of the gas cap is more difficult. Plus, there is no dip angle. I will explain the basics method on how to produce oil and gas simultaneously. First, the water is injected at the gas oil contact, so it will create a perfect barrier between gas and oil. Means there's an isolation between gas and oil, so they will not be mixed up. Due to low dip angle, the gravity effect can be overcome when injecting water at gas oil contact. Second, the water injector is not only injected at the gas oil contact, it is also being injected not only at the gas oil contact. The water is also being injected at the boundary of the reservoir. After the water is being injected at the location mentioned before, the wellbore is being perforated at the gas and the oil column. This figure shows wellbore orientation. I will explain on what is the meaning of this wellbore orientation. GP1 stands for gas producer. Next, the OP stands for oil producer. WI is water injector. So we can see here that the water injector is being injected at between the gas producer and oil producer, which means that it is being injected at the gas oil contact. Plus that the water is also injected at the boundary of the reservoir. So this will provide the energy for the production of oil and the gas. Just to extend a little bit information on this reservoir, if the reservoir happen to have low productive index, which means the porosity, the permeability is quite not favorable, higher number of injectors and producer is needed to support the production of oil and gas.
There will be two methods that been used for this reservoir, which is homogeneous simulation models and heterogeneous simulation model. For homogeneous simulation model, there will be 4 scenarios included in here, which are depletion scenario, conventional scenario, gas cap containment scenario, and simultaneous production scenario. So actually, what are the significant difference between all these four scenarios? For depletion scenarios, the oil has been produced from 4 injectors and there will be no water injected in the reservoir and no gas cap that been produced from the reservoir. That's the significant difference from all of these scenarios. There will be no gas cap that been computed from this scenario because the gas cap do not been produced. And the abandonment pressure that be abandoned for the scenarios is for 1000 psia. For conventional scenario, the oil is produced from 4 producers. The water is injected in 3 peripheral water injectors, which are WIEWB, WIEWT, and WINS, but not at the gas oil contact. And the gas cap is not being produced here, and because it been used as the pressure support for the reservoir as the fluid expansion, and also no attempt to compute the gas recovery. For the gas containment scenarios, there will be, for gas cap containment scenario, there will be 4 oil producers that been used here, and the water is also been injected with the 4 injectors to the reservoir, but no gas cap being produced here too. But the gas cap is being used to be expanded downward as the pressure support and also as the fluid expansion. Lastly, simultaneous production scenario also have water been injected there with 4 injectors, and also the oil being produced with 4 producers. The significant difference here is the gas cap is produced through the gas cap producer, which is GPI, simultaneously as the oil column is depleted, and the water ejector at gas oil contact provide pressure support for the gas cap and the oil column. So based on this table, we can see the result of all of these 4 scenarios. For gas recovery, for gas containment and simultaneous production having 22.6% and 40.3% respectively, because the gas been produced from the reservoir. But for gas cap recovery, there will be no attempt that been used to calculate the gas cap recovery for depletion scenarios and conventional scenarios. But there will be attempt to calculate the gas cap recovery for gas cap containment and simultaneous production. But the result for the gas cap containment and the simultaneous production having significant difference, because the simultaneous production we produce the gas cap from the reservoir, but for the gas cap containment we not produce the gas cap from the reservoir. So from all of these 4 production scenarios, the simultaneous production scenarios had been chosen as the most viable production option because it increased early cash flow, accelerated gas slate in a ready gas market exists, and also the magnitude of the increase in net present value is highly dependent on the assumed gas price forecast and discount sale.
The last part of this SPE paper is about the effect of different heterogeneity, since in real life most of the reservoir are heterogeneous. So we want to see how permeability variation affecting the process of simultaneous gas cap and oil column production. As we can see in the slide, the method that was used to see the effect of heterogeneity is by using 2 different geostatistical models. The first one is layered essential and the second one is variable essential. And also for both models, we use the probability density function of permeability that was used is in log normal distribution, which you can see in the shape, where large percentage of the permeability values is low. The mean is about 2,500 and the maximum permeability is 760 millidarcy. We go back to both models. There are difference between both models. The first one, the layered one, is that the permeability of layered essential is continuous in the aerial plane, while vary significantly in the vertical plane. And the other side, the variable sand shell, the difference is that the permeability of variable sand shell is vary for both aerial plane and also for vertical plane. And also to test the effect of different heterogeneity of reservoir, unconditional simulation was used to generate 5 usually likely realization for both models each. So it means that for layered sand shell, there are 5 equally like realization or ELR, and also for the variable sand shell also have 5 different ELR. For all ELRs, the parameters that were used are the same, but different only for the permeability. Okay, for the result from the experiment, the first one is for the layered sand shell. As we can see from the graph, this wide range of 5 different ELR indicates that heterogeneity of reservoir lead to different water oil displacement efficiencies. So it means that the heterogeneity affecting the oil recovery for different permeability. Although the average is same with homogeneous model, but it is just by chance. Still, we can conclude for layered sand shell, the effect of heterogeneity is big for oil recovery. The gas cap recovery, as we can see from the graph, the range is very narrow, and also the average is quite close to the homogeneous model. We can conclude that both range and the average results indicate that heterogeneity does not significantly affecting the gas cap recovery. The effect of homogeneity on gas cap recovery is minimized because the gas can outrun the advancing waterfront. Moving on to the variable sand shell, the range is quite wide. We can conclude that the 5 ELRs model ranging very significantly. It means that the heterogeneity is very affecting the water displacement efficiencies, and also concurrently affecting the oil recovery. And also the average percentage of 5 different ELRs of oil recovery for variable sand shell is very far from homogeneous model. Yes, the heterogeneity does affecting the oil recovery. Continue to the gas cap recovery of a variable sand shell model. From the graph you can see the range is quite narrow, and the average is very close to homogeneous case. This range and average results indicate that heterogeneity does not affecting the gas recovery. For a short conclusion, for both models, gas cap recovery is relatively constant. Thus, the revenue of gas cap will be higher for project NVP, which is net present value, if the heterogeneity is low. But if the heterogeneity is high, the technique of simultaneous production of for both oil column and gas cap is also attractive because the early gas production will increase the NPV.